Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Welcome to the course of Introduction to Computing, CS101. It's lecture number 49, and today we'll discuss about architectures of computers. So, what is today's agenda? We have already covered central processing units, components of certain processing units, and working of a CPU. Today we will discuss about architectures of CPU and some popular processors that are available nowadays. So as you know, memory holds both data and instructions. The arithmetic logic unit is capable of performing arithmetic and logical operations on the data. So you have already studied this concept of ALU. This is the concept which is called arithmetical logic unit. This component is responsible for performing arithmetic and logical operations on the data. So the main goal is to play with the data and transform data with the help of arithmetic and logical operations. So which part of the CPU deals with this type of operations? The answer is ALU. And memory is the area where both the data and instructions are stored. And there is another area in the processor which is called a register or registers, and we name those registers as L1, L2 and L3. Okay, we have seen these concepts before, but for a recap we need to be at the L1 cache maybe is 80 MB and then 16 MB, and these are the storage sizes of your processor registers. So there is another memory which is called a cache memory. We call this a cache memory, and these are the registers where processor stores data on temporary basis during execution. So the processor register is a quickly accessible location that is available to a digital processor, a central processing unit. And what are the functions of registers or these caches? Registers usually consist of a small amount of fast storage. What we mean by small amount of fast storage, this means registers are similar to RAM, although some registers have specific hardware functions and may be read only or write only. So some registers are read only and some registers are write only, but the registers are very small in size as compared to the RAM. In case of RAM, the RAM could be from 8 GB, 16 GB, 32 GB, 64 GB, 128 GB, but the size of the registers that are relevant to the processor is very small as compared to the RAM. Their relative sizes are 8 MB, 16 MB, 64 MB, 128 MB, and so on. So these are the registers that are available to the processor, where the processor stores data on a temporary basis during execution of different instructions. The control unit controls the flow of the data within the CPU, which is fetch execute cycle, and the input arrives into the CPU via the bus. So bus is the main channel where the CPU receives input from different input devices via bus, and output exits the CPU via bus. So bus is the main channel where the information is traveling from different components of the computer to the CPU, and from the CPU to different components of the computer. So this is all about CPU and memory and registers. So let's move on. CPU architectures. There are two primary architectures used in today's environment. One is called 32-bit architecture. You have installed so many applications in your desktop applications or on your mobile phones. Some softwares, almost every software has extensions like x86 and 64-bit. You have seen this multiple times, so many times. So what does this mean, x86? This means 32-bit architecture, okay? And what does this mean, 64-bit, x86, 64-bit? This means 64-bit architecture. We have other architectures like Titanium 64 and AMD 64. These two architectures are for, this is for Intel and this is for AMD. So what does this mean, 32-bit architecture and 64-bit architecture? This means a word size. What should I say to it? This is a word size. This means that a processor can consume a word size of 64 bits in 1 second or in 1 millisecond for processing. So these are the standard word sizes. One is 32 bit and the other one is 64 bit architectures. So these architectures are different in the data path width. When we are purchasing 32-bit architecture or 64-bit architecture, this means that the data path differs also in width, integer size, and memory address locations, etc., that the processor is able to work with. So 32-bit architecture always has a different data path width, integer size, memory address width as compared to 64-bit architecture. 64-bit architecture is recommended for most applications nowadays. So let's talk about popular processors. When you go to the market, you will see two series of the processors that are very popular. One nowadays, one is the Intel, which is the most popular and has a very big market share in computing industry. One is the Intel and the other one is the AMD. Similarly, we can see like other technologies companies as Google, Amazon, and so on. Those are software development companies making different software products. Similarly, there are some processor industries available in the market. One is the Intel and the other one is the AMD series. So Intel stands for integrated circuit. This is the abbreviation of this integrated circuit, and it is an American company, multinational company, multinational corporation and technology company. Its headquarters is in Santa Clara, California, and in Silicon Valley. Silicon Valley is very famous for different uh, technology giants like Google, Facebook, Amazon, Apple, etc. So Intel Corporation headquarters is in Santa Clara, California, Silicon Valley. And who is the inventor of this popular company? The inventor's name was Robert Noyce, and it has one of the expensive processors available in the market. So if we talk on a scale of 1 to 10, Intel processors comes at a scale of 4 to 10. So Intel processors has a very huge market share and has a very good scale from 4 to 10. Going down price, one cannot get good performance of Intel processors because Intel processors are very famous. The point is its good performance. Intel processor performance are very good as compared to AMD. We will see this comparison later on in today's lecture. Intel's what is almost 50%, so power consumption is less by these processors. The second point is power consumption is very less, and the first point is its good performance. So these are the benchmarking factors which plays a very important role from consumers point of view. When a customer goes to the market, first the customer sees the good performance and the other one is the power consumption, long battery life. So this can relate to the long battery life. Low consumptions, this means long battery life. Let me write this, long battery life. Okay, so these are the points. One is the good performance and the other one is the power consumption of these processors. So these are the main reasons why Intel processors are so much popular in the market. If you want a laptop with a good battery life, then Intel processors should be the preferred. So always prefer Intel processors if you want a good battery life and as a good performance as well. For better video and good production sound, Intel processors are best. Examples are Intel Xeon, Intel Core i series. So this is a very popular series for mid-range consumers. Core i7, Core i5. Let me write this also: Core i7, Core i5, and so on. Okay. So Core i series is a very popular series, and the reason is for its better video and good production of sound. So you can buy Intel processors for your needs accordingly. Let's talk about its competitor, Intel's competitor, which is called AMD. AMD stands for Advanced Micro Devices, and it is also an American multinational semiconductor company based in Santa Clara, California, Silicon Valley. So these two companies, Intel and AMD Advanced Micro Devices, are in the same location, Santa Clara, California. And this company was invented by three innovators, Jerry Sanders, Jack Gifford, and John Carey. So what is the scale of AMD processors? If we scale a processor from 1 to 10, AMD processors comes at a scale of 2 to 8. The reason why it is preferable to a consumer, it's cheaper. The reason it's this processor is not much expensive like Intel, but it is a cheaper processor as compared to the Intel. If you are taking a minimum budget, a laptop or a PC, then preferring AMD processors is a good idea as compared to Intel processors. If your workload is not much heavy, if you are not editing your videos or making videos or some graphic applications, if you're not using such types of heavy applications, if you're not playing games on your desktops or your laptops, then you can prefer this AMD processor. It's cheaper as compared to Intel processors, and its budget is very minimum. So you can purchase AMD processors if you are not working or putting heavy loads on your computer, on your desktop. These processors consumes more power in comparison to Intel processors. So this is what we call a drawback of these processors. Their power consumption is high as compared to the Intel processors. And AMD, the second drawback which discourages most users to buy these processors, it's hotter while using. So AMD sometimes get hotter during when you are using or you're putting some heavy load on the processor. It sometimes get hotter. If you want a good performance and good compatibility, then AMD processor is not a preferable option. Popular processors in AMD series stands for AMD Sempron and AMD Athlon 64. But nowadays other categories also available, which we call AMD Ryzen processors. We will see this in later on today's lecture. So let's compare both the processors one by one. Now let's see Intel processor. It's more expensive than AMD processor, so you can say that this is the drawback or of this processor, that it is more expensive as compared to AMD processors. AMD processors are cheaper than the Intel processors. When we compare Intel with AMD in terms of performance, we can say that it's more efficient than AMD in performance parameters, and the AMD processor is not so much efficient as Intel processor. So you can say this is the drawback or pitfall of the AMD processor. The third bullet of the Intel is it runs cooler for longer durations. This is a very good point, that when you are using Intel processors on a daily basis on longer durations, then you cannot stuck with the heating problem of the processor as compared to the AMD processors, which heats up faster when you put heavy load on the processor. Your processors becomes generates more heat, and it becomes sometimes your applications crashes during running of the CPU. And the fourth point is it is faster processor than AMD, and AMD is not much faster as compared to the Intel processor. So as you can see from the differences, Intel beats AMD in many areas. Its clock speed is 2.93 gigahertz and its clock speed is 2 gigahertz. So you can see that the Intel processor clock speed is 2.93 and its clock speed is 2 gigahertz in different series. Intel has a series Core i3, Core i5, Core i7, and Core i9. Similarly, AMD has also the series with different naming conventions like Ryzen 3, Ryzen 5, Ryzen 7, and Ryzen 9. So these are the standard naming conventions used by Intel and AMD. Intel uses Core i3, Core i5, Core i7, and Core i9, and AMD uses different naming conventions when in processors. So the popular series of Intel are Core i3, Core i5, and Core i7. So these processors are a little bit cheaper when you are going in upward direction, like from Core i3 to Core i5 and from Core i5 to Core i7. The performance also matters, and the price also matters. So it means that Core i5 has a greater performance as compared to Core i3, and Core i7 has a greater performance as compared to Core i5. Intel releases families of chipsets called generations. The current one is the 8th generation, but today you can see on the Google that the current generation is not 8th generation, it is 11th generation. So Intel releases families of chipsets we are called generations, and today the latest generation is 11th generation and not the 8th generation. 8th generation name is Kaby Lake Refresh. Every generation has a name. As you can see, that 8th generation processor is called Kaby Lake Refresh. Each family in turn has its own line of Core i3, Core i5, and Core i7 series of processors. This means that Core i3, Core i5, and Core i7 series of processors have 8th generation. Similarly, 9th generation, 10th generation, and the latest generation is 11th generation processors. We can spot which generation a processor belongs to by the first digit in its 4-digit model name. uh, for example, the Intel Core i3 8250 belongs to the 8th generation. As you can see that this is the generation name, Intel Core i3-82550. The initial character after dash is indicating its generation. So you can see, you can figure it out that this is the 8th generation processor, and the generation family generation is Core i3. I7, sometimes this confuses a normal layman, that I7 means that the processor has 7 cores. So these are just the names to indicate relative performance. And if the generation name is Core i3, it doesn't mean that the processor has 3 cores. Similarly, Core i5 does not means that the processor has 5 cores, and Core i7 does not mean that the processor has 7 cores. These are just the names given to indicate relative performance. Cores, what are the cores? Cores are basically processors that can work together to accomplish more faster. So core are the dependent units within the processor that can work together to complete some task more faster way. So let's try to understand the naming convention of the Intel processor. As you can see that in the initial part, in the initial segment, this is the Intel brand name, which is called Intel Core. This is registered, and this is for the trademark, and this is the brand modifier. This is the brand, and this is the brand modifier. And you can see that after the dash, the first letter which states the generation indicator. And what is this? 65, this is called SKU, numeric digits. And product line suffix, this is generation 7 processor, product line suffix, and this is the processor normal word. So the generation indicator is this. Generation indicator is after the dash, and not this G7 processor is the name of the processor. So what does this mean? Special characters which comes like in this way, we have seen in the previous slide. G includes discrete graphics. Okay, so these are the different characters that comes at generation suffix. level. One is called U, the ultra low power. The U rating is only for laptop processors, and these draw less power and are better for the battery. So these are the native processor generations. Uh, the second one is the Y. This is also the low power, typically found on older generation laptops and mobile processors. There is also a power optimized for desktop processors, and there is a fourth one that is called quad core. The Q rating is only for processors with four physical cores. Having four physical cores, we call them quad core processors, and this is called H high performance graphics. The chipset has one of the Intel's better graphics units in it, mostly suitable for gaming or performing some higher level graphics like computer aided design, manufacturing types of softwares. We can purchase this high performance graphics. And then there is also called G, includes discrete graphics typically found on laptops. This means there is a dedicated GPU within the processor. So one is called the GPU and the other one is called the CPU. Nowadays laptops and desktops are coming with two combinations, either in CPU and GPU, both, or separate units as well. So as I told you before that AMD recently launched another processor which is called AMD Ryzen processors, and these are the very popular nowadays and cheaper as compared to Intel processors. With respect to performance, AMD Ryzen beats Intel's in some areas of the market. Similarly, Intel generation names are Core i3, Core i5, i7, i9. Similarly, AMD series are named as Ryzen 3, Ryzen 5, Ryzen 7, and Ryzen 9. As you can see from the picture, this is Core i9 and this is the Ryzen 9. So these two processors are look similar but actually different. So what is the difference between Ryzen and Intel? The Ryzen 3 CPUs come with 4 cores and 8 threads, while i3 CPUs come with 4 cores and 4 threads. So you can see that the Ryzen processor having 3 CPUs, Ryzen 3, it has 4 cores. Core i3 has 4 cores, but 4 threads. But in threads terminology, Ryzen has a better performance. Similarly, Ryzen 5, it comes 6 cores and 12 threads, while R5 CPUs come with 6 cores and 6 threads. So in threads area, Ryzen beats Intel in performance. Similarly, Ryzen 7 CPU has 8 cores and 16 threads, and Core i5 CPUs at 8 cores and 8 threads. So you can see that in threading, multi-threading environments, Ryzen has a very good performance as compared to the Intel. So these are the benchmarks. As I have told you before that Intel Core i3, Intel Core i5, Core i7. Similarly, Ryzen 3, Ryzen 5, and Ryzen 7. These are the generation names of the AMD and Intel processors. So I hope you have understood today's lecture. If you have any question regarding today's lecture, you can reach me out on this email and I will answer you accordingly. So till then, your next lecture. Allah Hafiz and see you soon, inshallah.